Good day, everyone. I'm Dr. Ajith Peduru Hewa on behalf of support class. Where's my name? I'm Ajith Peduru Hewa. So our website, please go and look at this. So that is supportclass.com.au. All lowercase, support, class singular.com.au. So thank you for that. So let us speak or discuss this topic again. So last week we described that the quadratic equations, and we look at that if you provide us a parabolic graph, a shape of parabola, so there belongs to quadratic equation. So we look at how the equation is formulated according to the graph. Now today we're going to learn if we provide certain features of the graph, right? So if we provide x-intercepts or turning point details and the coordinates of one particular point on the graph. So then how do we plot the graph, or how do we actually first of all make the formula, or otherwise make the formula or predict the formula and also plot the graph. So in that case, so we introduce you two families of the quadratic equations. So three families, 1, 2, 3. So the first one is this model. So we use the null factor theorem to solve this equation. So in this one you can see, so y is equal to a within open brackets x, take away e, close bracket and open bracket again. So x take away f, right? So that's the equation given like that. So in this case you can say, right? So according to the null factor theorem, so assume that y is equal to 0 and then find the values of x, right? So that is how we, so for example, I will take this one. If y is equal to 0 and then x supposed to be, right, or it should be a is 0, so a is not 0, right? It has to be a is not to be 0. So then just forget about that option. So then either, in that case, either x take away e is equal to 0 or x take away f is equal to 0. So what does that mean? Then in this case, it is x is equal to e, or x is equal to f. Hope you got that. So that is what you call solving this, the value of x. It could be either e or f, right? So that's what you call null factor theorem, right? So if you know the values of e and f, then you can find what are the x-intercepts of the parabola. So if you don't understand that, just wait and see how do we do that, right? So, okay, the second type right? So, okay, hang on, this first type. So the null factor theorem style. So you need to have, right? So you need to have two x-axis intercept as well as coordinate of one other point, right? So then what you need to have? So you need to get, so 2x coordinate, this one and the other one. 2x coordinate as well as any point of the graph. The x and y coordinate, it is the point. So x and y coordinate of this graph, of this point, sorry. So that's what we want to solve this equation. If that, right? If you, in other words, if you provide with two x-intercepts and one point on the graph, the coordinates, so then you go for this null factor theorem method. So then what you use then? So you use this formula to solve that equation, right? So that is the family one. And second family is totally based on, this is the turning point model. Remember that? The turning point model. So we have discussed that turning point model. So what is this? This is the x-axis of line of symmetry. This is the y coordinates of the turning point, right? So in other words, I just explained that one too. So in that family, you get something like this. In that family, right? So what you get is, so this is the line of symmetry. So simple hash is this. That is the x coordinate. This is simple hash in the formula. See the simple hash in here? So that is what it is, right? So that is actually x coordinate so it is x coordinate of symmetry. So this is a symmetrical line of this graph. So this is the x coordinate of that, which is simple hash. So what is this y? As a turning point, this y coordinate is actually k. K is y coordinate of the graph. All right. So in that case, so if that class or that family, right? So in that family, so this is the equation common for them. So if you get, for example, if you get coordinates of the turning point, remember that? Coordinate of the turning points and one point on the graph. For example, so if you get these coordinates just in here, this is the turning point. So X and Y of that. And also the coordinates of one other point, X, Y, any other point on the graph. So then advise you to follow this equation, and then it is belongs to that family, right? So it should be in that family. So another one, the third one is a polynomial type of equation, like polynomial type of family. So this we call polynomial equation. See? So A is a polynomial, B is a polynomial constant, C is a polynomial constant, right? And yeah, so these are the constant. And variable polynomial are Y and X. So the constant polynomials, A, B, C, right? So you have to find that method by three simultaneous equations. Right? You need 3 points then. 3 points on the graph. So you can have 3 equations substituting, right? So A, B, C, right? So you need 3 equations. 3 equations from 3 points. So we will look at how to do it as well. Right? So that's the third type. So that's the third type of solving the parabola. So you need what you need. So you need A, B, and C points. So that's all you get, right? That's all you get. The coordinates of A, B, C, three places. All right. So all right. So if you got that point, so then we just look at what we are talking about and how do we these calculations. So in order to do that, I will direct you to this exercise. This book is the Cambridge Unit 1 and 2 VCE. So that is the majority of students using this one. Using the Cambridge book. For VC exam.